Okay, cool. So when we're estimating the mean, it's very similar to doing our proportion. What we have is it's the same kind of idea because remember your proportion was your test statistic minus critical value. Nah, let's just do it this way. So when we did proportion, what we had is p hat minus e, which is less than p, which is less than p hat plus e. Now we know that the population proportion lived between these things, where E was equal to Z alpha over 2 divided by the square root of P hat times Q hat all over N. Now remember, this thing right here is just the standard deviation, okay? So this is critical values times the standard deviation. Now when we're doing the mean, when we want to calculate the mean, it's the exact same kind of idea. So you still have your test statistic, because it's your sample. So you use this to estimate this number, right? So you know that the mean, the actual mean, is going to be your test statistic minus your error, so your test statistic plus your error. So it's got that exact same look to it. Now your error is calculated this way. So it will be equal to T alpha over 2 multiplied by S over the square root of N. And that is if sigma is not known. Or you're going to do E is equal to Z alpha over 2 times sigma over the square root of N. And that's if sigma is known. So sometimes they give you sigma, and if they give you sigma, you're going to use this to find your error, okay? But again, it's still the same thing. It's a critical value times, remember, this thing's just a standard deviation. So it's the exact same kind of idea, critical value times standard deviation. So if you can do this, you can do this. It's so very similar. Okay, so what I'm going to do is I'm going to do one where they give you everything, and I'm going to do one where you have to do a little bit of work, okay? Because this will be quick, and this will take a little longer. So number 10 says birth weights in boys. It says use these summary statistics for birth weights of 195 boys. So what it says X bar is equal to 32.7 and S is equal to 6.6. Use a 95% confidence level. So what they want to do is, in this case, we want to find a confidence interval estimate for the mean. So we're going to do exactly this. I'm going to find this thing right here. So number 10, they said we know that X bar is equal to 32.7 Hg, and then S is equal to 6.6 Hg. I forget what unit to measure that is. Our nurse left, so I'll have to ask her next time. And I know that there was 195 boys, right? N was equal to 195. Does that make sense? So they've given us a lot of these values, and they want us to have a 95% confidence level. 95% confidence. So, what does the 95% confident give us? Why do they keep saying this thing? Yeah, the confidence level ties to what number?
The two tails.
Yeah, which gives us these critical values, right? So the confidence level gives us these critical values. Now my question here, what one are we in? Do we know sigma or do we not know sigma? Do we not know it or do we know it? Yeah, if you look here, they didn't give us sigma, did they? What they did is they gave us S. So we're using this for error, aren't we? Okay. Okay, so that means in order to find the error, I need to know what T alpha over 2 is. So they want to be 95% confident, so that means 95% is going to live here. Remember, a t-score is still a bell-shaped curve. Your table is just a little different. So what's the area in these tails? Okay, so the area in this tail is 0.025. The area in this tail is 0.025. So what I'm going to do is I'm going to go to my z-score table. Actually, to go to my z-score table, my t-score table, what do I also need? It says I need an area to tail, and I also need what? I need degrees of freedom, right? If n is equal to 195, what's your degree of freedom? 194. Yep, it's just one less than that. Okay, so it's 194. So we're going to go to our t-score table. So here's your t-scores. You guys notice that I don't see, I don't see 194 there. So what do you think you're going to use?
It's blurry.
Oh, it's really blurry, isn't it? Better? Yeah. Okay. So I don't see 194 here, so what you're going to do is you're going to use the number that's closest to it, okay? This isn't Price is Right, just get as close as you can, okay? All right, so, and then I know that the area in one tail was 2.5%, right? So what we're going to do is we're going to go up to the top. I know the area in a single tail was 0.025, right? And I'm going to track that all the way down to 200. So tracking that center all the way down to 200, I get a critical value of 1.972. So that means my T alpha over 2 is equal to, dang it, I just had it, 1.972. I said it out loud and everything. Oh well, old brain. Okay, so now we can find everything. We have it all. You guys agree? I have T alpha over 2, I have S, I have N, I even have X bar, don't I?
Yeah.
Okay, so let's find E. E is equal to your T alpha over 2, which is 1.972, multiplied by S, which was given, which is 6.6, divided by the square root of N, which is going to be the square root of 195. Don't forget to use N, not the degree of freedom, okay? I've seen that happen a couple times, so 195. And since there's no addition and subtraction, this is all multiplication. You can just plug it in just like we did with proportion. You don't have to worry about a lot of parentheses. So 1.972 times 6.6 divided by second square root of 195. And so it's really easy to plug in. You just like it says. So what I get is I get a 0. Let's talk about rounding. Man, I'm way out of frame again. Wait, I'm booking this. Okay, so remember we're estimating mu, right? And we're estimating mu, we're using this number right here. So what we're going to do is we're going to, use one decimal past the given data. Does that make sense? So I'm going to go to one beyond this. Is that clear? Like this is the given data? Okay, so I know I'm going to get 9, 3, 2, it's whatever. So that means my confidence interval, you guys see it? My confidence interval is going to be x bar minus e less than mu less than x bar plus e. So my x bar is going to be equal to that 32.7 minus this is 0.932 less than mu less than 32.7 plus 0.932. So when I do this, so I'm going to go to here, right? This decimal. So I got 31.77. So 31.77 less than mu less than 33.63. And this is an HGs, right? Don't forget units here. Proportion is a probability, so it's unitless, right? But this is not, so you have to have that. Not that bad, is it? Okay, like I said, it's going to take some practice. Don't get me wrong. That's a lot of letters. You guys agree? But we'll get really good at it, I promise. This is actually an easier section, even though it looks more complicated. This is actually much easier than what we did in Chapter 5, okay? Students just tend to do very well on this. But you got to practice it. So let me do one more from this type of idea, and then we're going to estimate sample size, and that'll be it. So let's do this because it's small. It says listed below are the amounts of arsenic in micrograms per serving in samples of brown rice from California based on, can you guys read that at all? Okay, so this is going to be based on the FDA. Use a 90% confidence level. Okay, so use a 90% confidence level. Food and Drug Administration also measures the amount of arsenic in samples of brown rice from Arkansas. Can the confidence interval be used to describe arsenic levels in Arkansas? So, since I wasn't very clear here, these numbers right here are arsenic levels in California, right? The very last question, it says, since these values come from California, can I use these values to estimate Arkansas?
No.
Okay, so no. You guys agree the second question is no. You have to have a sample that's, Yeah, it's got to be representative of the population, right? And this is representative of California's population, maybe, but nobody else's. Another thing that you have to kind of check is there should be some kind of normality check here. What they do in normality checks is they do a quick like dot plot, and if the dot plot actually comes to be somewhat bell-shaped, then the population was probably normal. So that's how they do it. So if I do a dot plot, what I have is I won't make you do a dot plot on a test, okay? I don't even know if I'm going to do this. I'm kind of run out of time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's not too bad. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, 9, 10. It's not very good, but whatever. So what I'm going to do is I'm going to plot all those points. So I got 5.4, which is going to be right here. 5.6, which is right here. 8.4, which is about here. 7.3. 7.5. 1.5. 5.5. 9.1. 8.7. Okay, so what this tells me is it's possibly a normal distribution. You guys see that I have a couple outliers with a lot in the middle? Like it's kind of stuffed around here. So it might have this kind of shape. You guys agree? It's kind of a stretch because I only have, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points, right? But it kind of looks like it's squished around here with some one outlier there. So I don't know. Normal, maybe, right? Okay, maybe. So yeah, I don't know. It might be stretching a little bit. So I'm not positive this is a normal distribution, but it's possible. But that's what you're looking for. You're looking for like a lot around the middle and then just a couple on the ends, right? Would it make sense if it looked a lot more like this? That would clearly show like a normal distribution.
Right.
Okay. Okay, so we don't really. It's close. I don't know. So what we have to do is, in order to find this, what I know is that we have to do x bar minus e less than mu less than x bar plus e, and they did not give me sigma, so I'm going to have to I'll have to use the t-scores. And this is where e is equal to t alpha over 2 times s over the square root of n. So that means I need to know a couple things, right? In order to find this, I have to find these values, right? So where does t alpha over 2 come from? What information tells me my t alpha over 2? Yeah, from your confidence level, right? So I know that my bell-shaped curve, because that's what I'm kind of claiming here, that this is 90% confident. So what's the area in these tails?
0.05.
Okay, 0.05, 0.05. What's my degree of freedom? Yeah, so we have to count them, right? Let's figure out what n is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You guys agree?
Yes.
Okay, so n is equal to 10, so degree of freedom is 9, right?
Yes, sir.
Because n is equal to 10. All right, so I'm also going to need to know, so I have this. Let's find t alpha over 2. So pop to my t-score table. I know my degree of freedom. I know my area to tail. So the area to single tail is going to be equal to the 0.05, and I need to go down to 9, right? Because that's the degree of freedom. So plotting this to 9 gives me, I got a 1.833. Yep, so I got 1.833. So this takes care of that, right? I know t alpha over 2. I also know n. What do I still have to find? I need to know s, and I also need to know x bar, right? Okay, so what I'm going to do is I'm going to use my calculator, because we're never doing this by hand again, right? I told you that. So let's pop these things in here. So clear statistics, edit. So in L1, oh, I was supposed to do that. In L1, it's supposed to clear, not delete. So in L1, what I'm going to do is I'm going to put in those numbers, and I'm going to do one variable stats, and it's just going to tell me what it is. I keep losing my page. I know. You know, I have a bunch of pieces of papers over here. I could make that happen. So, my numbers are 5.4, 5.6, 8.4, 7.3, 4.5, 7.5, 5.5, 9.5. Okay, so now that I have all the data values in there, how do you find the statistics? Stat, calculate, one variable stats, L1. So now I have everything. I know X bar is going to be equal to 6.635 because remember this was to the tens place, so I'm going to do one decimal pass, right? You guys agree?
Yep.
S is also going to be one decimal pass, so I'm going to go to here. So this is going to be 2.32. Remember that sigma is useless here. This is a sample, right? Okay, so now I have everything. So let's find E. E is equal to that 1.833 multiplied by S, which is 2.32, divided by the square root of N, which is 10. So what I get is I get a 1.418. That's good enough. 1.418. Now my confidence interval is going to be X bar minus E less than mu less than X bar plus E. Am I ever going to know that number right there?
No.
Nope.
Nope, you're just going to know these,
Lives
right?
in between.
Yeah, but lives somewhere between. So X bar is going to be equal to that 6.35 minus this error, 1.418, less than mu less than 6.35 plus 1.418.
And you have 4.1.
So I'm going to go again. Remember, it's one decimal past the given data, so I'm going to go here, okay, to the hundredths place. So it's going to be 4.93, 4.93, less than mu, less than 7.77. Not bad, huh?
Not bad.
Okay,
Good thing
so.
that wasn't 666.
Oh my, yeah, no doubt. Actually, 777. Lucky. I like that. It's a good day. Okay, so we have 7 minutes to do sample size, okay? Which will be plenty of time because it's handled very similar to what we did before, okay? Remember that if they give you sigma, they use Z and sigma as opposed to T and S, right? And you already know how to find a Z-score, so I don't have to reteach you that. Estimating sample size, what they've done here is it's the exact same error formula. All they do is solve for n, and I'm not going to do that again. I already solved for n once to show you that that's really the case. But this error formula is given for the one where they know sigma. Okay, so they've solved that error formula for n. Remember that error formula writes, if you solve this thing right here for n, you actually get that equation they're giving you, okay? So it's a little easier to solve than the previous one. So what I know is that when I'm trying to determine sample size, that n is equal to, it's z alpha over 2 sigma all over e all squared.
You know, hold on.
I absolutely can. Yep. What's funny is you have to use this one because if you don't know, you don't know n, so you don't know t, right?
Mm-hmm.
Okay, so this is how it's done. Remember that a t-score, the one that you don't know sigma is quite literally just an estimate for if you do, okay? So the value shouldn't be too far off if you're using, like these two things are really, really close to each other. Like S and sigma should be pretty close, right? And T and Z should be pretty close because they're estimations of each other. So even if you knew sigma, this value, this error, and this error should be pretty darn close. So it's definitely good enough. All right, so our example here is give me one. There we are. Gotcha. So mean IQ of attorneys, mean weight, male statistics students. Oh, whatever. Let's do that. That seems cool. So we're gonna do number 32. So it says in data set 1 of body data in appendix B, the one that's on the computer, not the one in the back of your book, right? Okay, so it says it includes 153 randomly selected adult males, and those weights have a standard deviation of 17.65. Because it's reasonable to assume that the weights of male statistics students have less variation than the weights of the population of adult males, we could actually assume that sigma would be equal to that 17.65. What they mean by that is, if you took all the adults males in the country or in the world, you guys agree that their spread is going to be larger than if I grab a small selection of, say, statistics students? Remember, adults that are probably more likely between the ages of 20 and 30 were probably, I don't know, I'm trying to be nice. They're usually young people tend to be more fit, right? Okay, so that's just what it is, because we get slower as we age, except me. But right. Whatever. So that's why they say that. Okay, that's the only reason why they say that is the variation is less. So since it's less, we can actually use the standard deviation from the sample and say, hey, that's going to be sigma. So how many male students? Whoa, how many male statistics students must be weighed in order to estimate the mean weight within all male statistics students? Assume we want a 90% confidence. And the sample size mean needs to be within 1.5 kilograms. Okay. So what we know is they've given us, they want to say 90% confidence. So when they say 90% confidence, what one of these things are they indirectly giving us?
The values and details.
Yep, the Z. So what I know is that 90% confident, eventually I'm going to stop drawing this. You guys are just going to know that, right? So that means this is 0.05, right? So that means area to the left is equal to 0.95. You guys agree? So that means Z alpha over 2, remember we got to go back to a Z table, looking at that 0.95, and it maps to 2.575. So 2.575. We've actually already done a 90% confidence level. Is that one? Am I right?
That's 99.
Oh, you're right. It's 1.645. Yep, 1.645. Yeah, that would have been 99. Okay, so now I know that Z-score. That's done, right? They also gave us sigma, which is going to be equal to, they said sigma is equal to 17.65 kilograms. And then they said the error. They said our error needs to be within 1.5 kilograms. Now the thing you have to be careful of is in the previous section, error was a proportion, right? It was a percentage. So you had to turn that percentage into a decimal, right? So if I say 2%, I mean 0.02, right? But since we're doing the mean, you don't have to do that same adjustment. Does that make sense? That this number is going to go here. Just be careful when you guys are doing it for proportion. Don't, if they say 2 percentage points, don't put 2 there. Put 0.02. 2%. Okay.
And this is number 34?
This is number 34. 32. 32. Okay, so we're done. So n is going to be equal to Z alpha over 2 is going to be equal to that 1.645 multiplied by sigma, which is 17.65, all divided by E, which is 1.5, and then I'm going to square the entire thing. And what's nice again, and since there's no addition and subtraction, just plug it in and so 1.645 times 17.65 divided by 1.5 squared. So what I get is I get 374.6. That's correct. Yep, 0.661. So whenever you're estimating sample size, remember this is the minimum amount of people I need, right? Mm-hmm. So 374 won't do it. It doesn't reach the minimum, does it? So you always round these numbers up for that's exactly right. So I'm not going there yet because all of a sudden my mind went to a bad place. I'm like, well, okay. So people. All right. So any questions? All right.